Today I want to talk about error messages in Python. And in particular I want to talk about exception handling, which is quite an important feature of writing code that does not break, that keeps working, even if things around it go wrong. You can imagine that you want to open a file, but the file is not there, and then you get an error message. How does your program proceed when this happens? You ask for a number to be put in by a user, and the user enters a name instead of a number. How does your program progress? And so forth. So what you don't want is to, every time there's an error like this, the program just to crash, give a Python error message, like you have seen many of them, of course, over the course, and that'll be it. It will be preferable if your program can just handle the situation. If your program knows what to do when a file is not there, when a user enters incorrect information, when a file does not have the contents you expect it to have, and so forth. Now, there are two types of errors that are helpful to separate. One is called a syntax error. A syntax error is an error that occurs because the code is not correct Python code in the first place. You maybe miss a colon, or you forgot about some comma, or you have the wrong parentheses, or you call a function that doesn't exist, and so forth. Many of the errors you will have observed so far are syntax errors. So syntax errors are errors when the Python code is not correct Python code in the first place. And those errors you cannot catch in the program, but they will be caught usually quite early on anyway. So that is not something you address with exception handling. That is something you need to fix as a programmer before you give the program to users. So the first thing I demonstrate here is a small syntax error, just so you remember what they look like. The second type of error is basically all other errors. These are called runtime errors. Errors that occur when the program is running. So not at the time of checking the code, but at the time of executing the program. And these can often be handled with exceptions. So I will show you two instruction videos here. One, how to catch exceptions. So for example, when you open a file and you want to but you might get an error that the file doesn't exist. What does your program do in that case? Or the second thing is how to create exceptions. If you define a function and certain input values are not allowed, then you might, what they call, raise an exception. You might tell the remainder of the program that is calling your function that there is a problem, that there is an error. And you can then try to catch this. In this example, we will ask the user to enter a number and then print this number to the screen. And we immediately use the int command that we have seen before to convert a string to an integer. So the user enters some text or numbers, and the int command converts this to an integer, which is then printed on the screen. But this creates problems when the int command is called with a string that does not contain numbers. And Python itself internally will raise an exception. It will raise the value error exception. So in the first demonstration of the code, we ignore this problem and we see the error message appearing on the screen. Then we revise the code to catch this exception with a try and except block. So we do try before the code that can raise the exception, and accept after that code, and then we catch a particular type of exception, namely the value error. And we show then a message on the screen that there is a problem. And then we continue with the program. And first I just showed you, like, if there is no valid number entered, maybe we can come up with some indicator that this is not a valid number, like -1. But that is actually not a great solution. Better is to only print a number to the screen if there is a number, and if there isn't, it should avoid this. And for that we can use the else command. You know the else from if and else, but else is also used with try and else. So the here else means if there is no exception. So there is certain code that is being tried. If there is an exception raised, one of the except blocks is called. And if there is no exception, the else block is called. In this example, there's only one except block, just the value error. But note that there can be multiple types of exceptions raised by the same function. And then they can be called in sequence by different except blocks. But then followed at the very end by the else block. In the next example, I want to show you not just how to handle exceptions, so exceptions that are thrown by functions in Python that you can then decide how to handle. For example, when you open a file or when you convert a string to a number, Python internal libraries might generate exceptions, and you might want to handle those. That is what we saw in the previous segment. In this segment, I want to show you how you can create your own exceptions, how you can raise them, as they're called. So you can raise an exception, which then can be caught, we call it catching exceptions, which can then be caught in another part of the program. And you can raise a standard type of exception. So for example, name error and value error, those are exceptions that are built into Python. Python knows what that means. And you can raise them yourself as well. You can raise sort of an imprecise way is doing it, to just raise an exception, but then you're not specifying the type, and that also means that when people write the except clause, they cannot fetch this exception instead of other exception. They would automatically fetch all exceptions. So that's not very good practice. You do not want to actually say raise exception. You want to do raise and then a particular type of error. Now, showing you how to do this, how to raise particular type of errors that you might have generated yourself, that is a little bit beyond this course, because we skipped a very important topic in object-oriented programming, namely inheritance. I wanted to skip that because I first want you to get familiar, and that takes a bit more programming experience, with how to divide your program in objects and how to think object-orientedly, and that's what we're doing at the moment in the exercises. But to create your own exceptions, you actually need to use inheritance. I'll show you here at the end of this video a quick example where we define a new class, and then in the class name we use parentheses and another class name. This means that we inherit. And without having to worry about that, these 2 lines of code just show you how to create your own type of exception, which you can then use in the code. In the final segment, I will show you how you can use exceptions when you open a file. So here it is quite common to use this. When you open a file, things might easily go wrong. There might be a problem with the file not being there, the file being moved, the file having been replaced, renamed. The drive on which you think this file is located might not be there. You might open a file that is actually online through a URL, and there's something wrong with the internet connection and so forth. So once you start using devices like printers or hard drives or mouses or etc., any kind of device that is attached to your computer, once you start interacting with them, the amount of things that can go wrong start to significantly increase. So these are really circumstances where you want to do proper exception handling. You want the program to not crash, and the program to know what to do if some file is unreadable, some printer is unavailable, some internet can't be accessed, and so forth. So I will stop talking here, and this is the last video of this course, so I hope you enjoyed it, but I will continue showing a little bit how this functionality works.